Quiz 2. All right. Now, listen to me when you're recording or marking this. Everything is worth 1. Now, you remember when I was doing that thing and I made the mistake where I wrote 10 and I should have written 4? But then I added everything else up right? Right? But I had all my concepts right? If you have something like that, you do not take marks off. Do you understand what I'm saying? Concept is right. That's all I care about. Okay? So, for example, in this first one, I need to multiply one thing 3 times. So I need 3 separate terms at the end. All right? There. 8x to the what? 4th minus 28 x cubed plus. There's not a lot to go wrong with there. You pretty much are getting that one right or wrong. Does everybody understand? Okay, there's not a lot of half marks available to you there. Everybody cool? Next one's the same way. What is it? 56k to the 4th.
Minus 48k to the 3rd cubed.
K to the 3rd minus
24k
k squared. Right? Again, you're pretty much stuck there. You're right or you're wrong. Because it's really only one step. Right? Number 3 gets a little hairier. If there was no negative 8 there, what would you have? Boom, boom. What would you have? X squared minus 8x. But there is a negative 8 there. If there was no 8x squared there, what would you have? You would have negative 48x plus 8. Then you would gather it all up. And you would get 48x squared. Negative 8 minus 48 is negative 56x plus 8. Now here you can have some half marks because a bunch of you will have done this in your head thinking that you can do that in your head, and you will tell me that the answer is negative 40, which is not correct. So if you have something here that isn't 56, but you remember to distribute twice, you may still have full marks, meaning you get the whole 1. Right? Same thing here. You're going to have 40a squared minus 35a plus 16a minus 14. Then you're going to add it up, and you're going to get 40a squared minus 19a minus 14. Yeah? Any questions up to the end of 4? All right, those are pretty easy. Number 5 looks exactly the same, except I made a small change. What is it? There's a y at the end. So I got to remember, if I know how to do x times x, do I automatically know how to do y times y? So there's no excuse for doing it poorly. 6x squared plus, what's that one? 12xy plus that one, 5yx. Does order matter? No. So it's going to be plus 5. I can write it the same way. And the last one, 10y squared. And then I just add it up to get 6x squared plus 17xy plus 10y squared. You've already done one just like 6 today. Also, you've just done 3 that are just like 6. But instead of going only twice, we now have to go thrice. Yes, Ash.
Have we added the 12 and the 5?
Yeah.
Did you add the x's and the y's too?
No.
Oh.
That's from grade 9, right? Nothing's happening there. P squared times 5p squared is 5p to the 4th. Plus 5p cubed. Plus 2p squared. Everybody good with the first one?
Yes.
Great. Then we do the second one. 2p now has to go all 3 times. So that's plus 10p cubed plus 10p squared plus 4p. That's the second one. And then the third one. Negative 2 times 5p squared is negative 10p squared. Negative 2 times 5p is negative 10p. And negative 2 times 2 is negative 4. And then we just add it all up. 5p to the 4th plus 15p cubed plus 2p squared minus 6p minus 4, which is, I think, exactly the same as the question I gave you in the first one. That's how nice I am. So give yourself a mark there out of 6. You be judicious with your marking. Since it doesn't affect your grade, the only person that screws up if you cheat on the marking here is you. The whole point of this is so you know what to study when it becomes test time. Now, number 7, there's what we do, and then there's, I messed around with a little to see who was paying attention during lecture time. So, obviously you know it's GCF because I tell you, factor the common factor out. So we're looking for the greatest common factor. What is it? 8. So 8 will come out, and then I write the answers here. Negative 9x squared plus 5. If you have that, you get your full mark. But there's something about the way that's written that I mentioned in class a few times that we could tidy it up a little. Aisha, what? Yeah, you would take out the negative because we don't like having that negative there in the front of this. If you're here, I'm happy you did the right thing. But if we want to do, go as far as we can, we like to get that negative out of there. So this would have been negative 8 and then positive 9x squared minus 5. But if you're here, you still get your full mark. Is everybody with me? This is just housekeeping. Yeah, you don't like a negative at the front of this. It's just something that we don't like. We like to get as far away as we can. Okay? So the same thing can happen in number 8. You know you're taking out what? X squared, because there's no number that works. But because you got that negative there, you kind of want to get that negative out of there too. So you would take out negative x squared, and that would leave you with 2x to the 6th minus 9. But, again, I will accept x squared coming out and negative 2x to the 6th plus 9. Both of those are fine. Everybody good? All right. Anything change in number 9? It's just bigger. I got to take out the numbers and the letters that go with everything. Well, right away I see that guy's only a number. So can I take out any of the letters? No, I can only do a number. What number goes into all of them? 3. So a 3 is coming out. And then I rewrite it with my GCF first, 3, and then all my answers. What's the first one? Negative 6. Keep going while my computer thaws. If you got to there, am I happy? Yes. would we write that a different way if this were a perfect world and you were all A+ university honor students? Would we write that a different way? Yeah, we'd move the 6 to the front, then the p squared, then the p, and this 6 at the end. In a perfect world, this would be written 3 10p to the 6th minus 8p squared plus 3p minus 6. But this question was written in the wrong order, wasn't it? So it's okay to leave it like that. Is everybody all right? I do not want you sweating about how to write out the right answer. Do you understand me?
Yes, sir.
Just do the math to get to there. This is not math. This is tidying. Everybody understand? All right. Same thing over here. What's the biggest number, though? 6. And then we do it again. 7 plus 3y squared. Ooh, Myers, you snuck that one in there. It's a different letter. Did I catch anybody? I wouldn't take marks away anyway. Minus 5x plus 8x squared. Yeah? Down here, are there letters that work in all of them? M and N, and a number. So I need all of it here. What's the number? 3. What's the letters?
M squared, N squared.
How do you know how many?
You could go up to the number that they all share.
The most you can get out of any one term is the 2, right? That guy can cover 2, that guy can cover 2, that guy can cover 2, that guy can cover 2. Then I rewrite 3m squared, n squared. Then I do the math. 12 divided by 3?
4.
4m, 4n, 4. Plus 7n cubed. 5, 2. Minus 4. That's it. Because the m squared and m squareds cancel out. Gouda? Great. And the last one is another one of those ones where we could take out a negative. What's coming out? Negative 2x squared. So negative 2x squared. And first one? Y to the 7th minus 8x squared. Or 2x squared negative y to the 7th plus 8x squared. Give yourself a mark out of 12. You decide what you get. And I will get that from you at another time. Is everybody good? Yes? All right, here's what we're going to do. We're going to go over the rest of page 131. Then you're going to have a little stretch and talk to your friend, break for a minute. Then we're going to go on to 132, which we are going to do as notes. Even though 132 has nothing new on it, there's a couple of things that are weird on it. Okay? Okay, so everybody to 132, please. 131, I'm the worst kind of liar. 131, of which you have seen the first 5 questions already from yesterday. What's weird about 6? The order's weird. So what do? Change it. This is x squared minus 9x plus 20. Now it's super easy. What do I have to multiply to? 20. And what do I have to add to? Negative 9. Is it 1 and 20? Is it 2 and 10? Is it 4 and 5? Yes, but they have to be negative because I want a negative 9. So it is x minus 5, x minus 4. Is this allowed? Yes. Because the signs are the same. Order doesn't matter in multiplying. 5 times 2 is the same as 2 times 5. That is called the commutative property. I will never make you know that word. Commutative. Multiplication is commutative. Everybody good? All right. Number 7 is written properly or for math class? Math class. Why? Because that 0 is there to remind you that I need to multiply to 64 and add to 0. What is it? It's not 1 and 64, is it?
No.
2 and 32?
8 and 8.
4 and 16? 8 and 8?
Yeah.
Yes, because 8 minus 8 will get me 0, won't it? So I have 8 plus 8, 8 minus 8. Now, the intelligent ones among you, and I shouldn't have said that, that's the wrong word for it. The insightful ones among you will make this connection that I have already made. That shouldn't be there. So this should be written as x squared minus 64, correct? And you can quite plainly see that the first answer in the factoring, x, is the square root of x squared, isn't it? And the second answer in the factoring, 8, is the square root of the second one. Right? So, looking at number 8, as insightful people, what do you recognize shouldn't be there? The 0. Oops. So now I have, hey, wait a minute, that's not x squared, that's x to the 6th. Of course you can square root it, because when you square root it, you get x cubed, don't you? So this would be x cubed plus what? 12. And x cubed minus 12. And the beautiful thing about this unit is, do you ever have to be unsure? No, because you can check. Is x cubed times x cubed x to the 6th? Is 12 times 12 negative 144? So we know we're right. If we made the mistake and just said, oh, Meyer says it's just x and x, and we wrote it like that, and then I went x times x is x squared, but oh. See what I'm saying? All right. Back to number 9. Number 9's a normal one. What do I got to multiply to? 18. What do I got to add to? Negative 11. Is it 1 and 18? Is it 2 and 9? Of course it is. How do 2 and 9 make negative 11? They both have to be negative. So it is x minus 2 and x minus 9. Now, if you were not here yesterday, this looks like magic to you.
Yeah.
Right? All the rugby guys, because they left before we got the lesson, and the people that were absent, this looks like magic. Right? But all it is this. If I gave you this, can you run the shortcut there? Because there's no coefficient, right? So that answer is x squared. 7 minus 4 is positive 3x. 7 times 4 is negative 28, correct? All we're doing is reversing that. Pretend you didn't know this, and I said, I want the factors. Well, you know to get that, you have to add two numbers. And to get that, you have to multiply those same two numbers. So we need numbers that multiply to negative 28 and add to 3. So we do our factors. 1 and 28, that won't make 3. 2 and 14, that won't make 3. 4 and 7, that will make 3. If I do 7, take away 4. So it is x plus 7, x minus 4. Is that good for all you rugby people? Ethan, you making sure you're getting that texted out to your friends so they know how to do it too? Okay, just making sure. Because I wouldn't want your friends not know how to do it either. I know. But I've taught you a lot of stuff in this before this class that you haven't demonstrated this class, have you? All right, so where were we? We were right here. Okay, so what don't I like about 10? The order's fine. I don't like that 2 out in front, which means I got to get rid of it. How do I get rid of times 2? So divide by 2. If that's going to work, it has to work all the way across. Does 28 divide by 2?
Yeah.
Good. Does 26?
Yeah.
Yes, so I'm okay, aren't I? 2x squared plus 14x plus 20 plus 13. Now, all of you remember me saying in my loud and obnoxious voice that you do not like, sometimes you have to factor more than once. So you look at that and you say to yourself, self, that looks a lot like all this other stuff. So we try it. Are there numbers that multiply to 13 and add to 14? Yes, there are. What's 1 times 13? 13. What's 1 plus 13?
14.
14. So it is 2x plus 1, x plus 13. Everyone forgets the 1 and the 13 because 99 times out of 100 when I'm doing this with you guys, is it 1 and 20? No. This time, is it 1 and 13? No. Yes. Okay. All right. What's different in 11? It's to the 4th, right? You're intelligent young people, though. When it was x squared, it was x and x. So what is it when it's x to the 4th?
X, X, and X, and X.
Yeah. X squared. So this is just going to be x squared and x squared because 4th to 2. Right? Other than that, does it change? Nope. I got to multiply to negative 10 and add to 3. What are they? Is it 1 and 10? No. Is it 2 and 5? How will 2 and 5 get me to positive 3? 5 minus 2. So it must be the 5 is positive, the 2 is negative. Good gravy. Hello. Yes, I can. Kingston, your turn. What's different in 12? There's a b squared. Well, if the a squared makes a and a, what must a b squared make? B and b. Does anything else change? No. So when you tell me you don't know how to do this, it looks different. What do? Stick a pencil in my eye. Because it's garbage excuse, isn't it? You know how to do it. What? I need numbers that multiply to 36 and add to 12. Is it 1 and 36? No. 2 and 18? No. 3 and 12? No. 4 and 9? No. 6 and 6? Yes. How will 6 and 6 get me to negative 12, though? They both have to be negative. Minus 6b, minus 6b. Is that okay? Yes. Can we write it tidier? Because math is all about tidiness. What would you write instead of that big long thing? A minus 6b all squared. Is everybody good? Okay? Everybody's good? Now, if you weren't here yesterday, you missed why this works. We drew it out with algebra blocks and everyone was like, yeah, okay, I see that. You guys just got the shortcut, which is just the reverse of the shortcut that you already knew. Kind of like if someone tells you a shortcut to get to your house and you say, I got to go home. I'm lost. You just reverse the same shortcut and you get home. Right? That's not what I said. That is not what I said. It might be. I recorded it. I could check it if I wanted, but I won't. Regardless, did you understand the concept? Well then, pie hole. All right, is everybody good? Stretch break, talk to your neighbor break. Go. That's what this break is for. You have a minute and a half to do so. You have a minute and a half to do so. All right, class. Class. Class.
No.
All right. We are looking at page 132. And we're going to do something a little different right now. We're not going to do some of these together because some of these you already know how to do, correct? So let's look at number 1. Is number 1 something that you already have the tools to do? Yes. So we're going to leave number 1 because everybody knows how to do it, right? It's multiply 2, add 2, right? Do you have the skills to do number 2? Why? What are you looking for in number 2? Numbers that will multiply to 20 and add to 9, correct? Is number 3 set up in such a way that you can do it? Not right now, so we're going to talk about number 3. Because remember, math rules never change, just the looks. So, what do you see there and there and there and there? Like terms. Do we know something to do with like terms? We're going to collect them. How many x squareds are there? 2x squareds. How many x's are there? No. Negative 12 x's. And what's left over? 8. That's starting to look like something we can deal with. What don't we like there? I don't like that 2, so I got to get rid of it by division. Can I divide that 2 into everything? Yes. So we can go ahead and do so. 2. That's going to get me 2x squared minus 6x plus 4, correct? Now that looks like something we can deal with. It's a multiply add 2 situation, isn't it? Okay, so I need to multiply to what? 4 and add to what? 6. Does it happen? Is it 1 and 4? Is it 2 and 2? So since there's nothing that matches up, is it done? Yes. Do not try to force the math when it's not there to be done. Is everybody with me? All right. Look at 4. It looks tricky because right now it's a trinomial. But is it? There's like terms. What do you see there and there? 3k squareds and 15k squareds, which is how much? 18k squareds minus 18k. Now what do you see? No. They both have 18 and they both have a k. So I can take out 18k. What goes first? 18k. What's in the bracket? K plus 1? Minus 1. Yeah? Look at 5. Is it a trinomial? Nope, so it must be GCF, right? What is the GCF? 6 x
6x
cubed
y.
and a y. And then you already know how to finish that off, right? So I'm going to leave that alone and let you finish it. 6. Do you know how to deal with that?
Yeah, 9.
I've given you the shortcut, but even if you didn't have the shortcut, the way I've written it there, it's the multiply, right? I need numbers that multiply to 81 and add to 0. So everyone's okay with 6. What's different about 7? What's different about 7? X to the 4th, isn't it? Okay, so that must mean this is really x to the 4th minus 256, right? When it was x squared, we did the square root, yeah? So let's try that. What's the square root of x to the 4th? X squared. What's the square root of 256? 16. X squared minus 16, right? Would we stop there? We could, but would we be right? What do you see there? It's the same thing as that, isn't it? There's a squared and a square. So we know we can't do anything with that because it's not minus, but here, what's the square root of x squared? Plus, what's the square root of 16? 4. Then I do it again. Everybody with me? Okay. Up to there, you guys have all the skills you need. Now something weird happens in 8. Now some of you have already been through some classes with me that we've done a little bit of factoring. What do you want to do there and there? Aisha, you want to expand that, don't you? Everybody agrees? So let's do that. I'm going to expand, and I'm going to work over here because I want some empty space. What is the first one? X squared minus 2x. Everyone agree? Okay. What is the second one? Plus 3x minus 6. Everyone agree? What do you see there? Like terms. So what do? Collect them, which gets me x squared plus x minus 6, correct? That looks like a multiply-add situation, doesn't it? Do I know numbers that will multiply to negative 6 and add to 1? What are they? Is it 1 and 6? Is it 2 and 3? Yeah. Right. So x plus 3 and x minus 2. Does everyone agree? Now, look closely. What do you see there and there? X minus 2. What do you see there and there? Does everyone see that? Now, stop for a second. This took 3 steps, yes? What if I did this? X minus 2 equals the letter A. Everyone okay with that? So what is this part of it right here? Instead of being x times x minus 2, what is it really? It's x times A, correct? Everybody see what I've done there? Okay. Plus, there's another x minus 2. So this is 3a, isn't it? Now what do you notice about that and that? What do they both share? They both share an a, so I can divide out an a, can't I? A, x plus 3, correct? What's a? X minus 2. So what do I write there? One step. Do you need to do this fancy move? No. But what's easier to deal with? I think this one. That's just me. Picking up what I'm putting down? If you ever see the same polynomial throughout a polynomial that's in brackets, you can always substitute it with a single letter and come back to it at the end. I usually use A. Look at the next question. Would A be a good letter to use? Why? Because there's A's in it. So what would you give it? Sure, W. It wouldn't matter. But you got to remember that A minus B is no longer A minus B. Now it's W. And then we can rewrite it, can't we? What's this become? 2AW. Aw. What's this become? BW. What's common to both of them? W. So I divide both sides by W. W goes to the front, and what's left? 2A plus B. There is no W in the original question. Who put W in the original question?
You did.
I did. But W equals A minus B, so what do I write here instead? A minus B.
Wow.
Okay? Now, if I expanded this all the way out and gathered all the like terms and then factored it, I would get that. Is everybody with me? Now stop for a moment, look at 10, and tell me what's going down. It's not right, is it? These guys look similar, but aren't. What is the thing that I am allowed to do to change a sign? Because this tells me I have a positive 2x and a negative 3, correct? This tells me I have a positive 3 and a negative 2x. If I'm allowed to divide and multiply by all kinds of ones, aren't I? Because does that change values? And is 1 common to everything? So if I divide this side by negative 1, does that change any values? No. So I'm going to have x, 2x minus 3. And I'm going to take a negative 1 out of there, right? So I've said negative 1 is my common factor, so it's got to move to the front, doesn't it? What's already there? Negative 5. What's negative 1 times negative 5? Positive 5. And now what do I have in here? 3 divided by negative 1 is what? Negative 3. Negative 2 divided by negative 1 is what? Positive 2x. Now, what do you see? Are they the same? They're just a different order. Now, can I do the substitution thing? Would I use A? Could I use A if I wanted? Could I use I? Could I use a fish? It wouldn't matter, would it? But I don't even need to anymore, do I? Because we know that the A is going to be out by itself, and that A is going to be what was in the brackets, right? So what's going to be out by itself? 2x minus 3. What's going to be left over? X plus 5. And you're done. Is everybody good? Homework tonight is 2 questions. The last 2 questions on this page.
You're assigning too much homework.
I know, right? And I'm going too fast. Look at all the concepts we covered. 1.
So much.
Now, yeah.